On the 9th of July, 1958, in a remote bay in Alaska, the ocean stood up. Not a swell, not a wave you have ever seen. A wall of water, 1,720 feet tall, higher than any building humanity has ever constructed. It happened. It was measured. It stripped a mountainside down to bare rock. And the next collapse is already mapped, already cracking, already loading. This is scenario 0. Today, the wave, taller than the sky, Lituya Bay. A 7-mile gash of water cut into the Alaskan coast, fed by 2 glaciers, ringed by mountains that rise straight from the tide line. On that July night, 3 fishing boats lay anchored near its mouth. Aboard one of them, a man named Howard Ulrich and his 7-year-old son were trying to sleep. At 10:16 in the evening, a fault beneath the bay slipped. A magnitude 7.8 earthquake tore through the mountains, and at the head of the fjord, 40 million cubic yards of rock, an entire mountain face, 90 million tons of stone, sheared off and fell 2,000 feet into the water below. What followed was not a tsunami in the way you imagine one. An ordinary tsunami is the whole ocean moving, a long, low surge, born of the seafloor shifting. This was something else. This was displacement. 90 million tons of rock hitting the water like a fist driven into a full bathtub. The water on the far shore did not flood. It climbed. In seconds, a wave surged up the opposite mountainside to a height of 1,720 feet. For comparison, the tallest building on Earth, the Burj Khalifa, stands at 2,717 feet, and the wave at Lituya would have swallowed it 2/3 of the way to its spire. To understand why Lituya was so monstrous, you have to understand the difference between the 2 ways the sea can rise against you. The first is the tsunami, you know. An undersea earthquake lifts a vast column of ocean across hundreds of miles. That energy spreads thin. It crosses the deep ocean, almost invisibly, then steepens at the coast into a surge of 10, 20, perhaps 100 feet. The second kind is the megatsunami, and it obeys a crueler arithmetic. It does not spread its energy across an ocean. It dumps it all at once into a confined space, a bay, a fjord, a reservoir. A solid mass falls into water, and the water has nowhere to go but up. The narrower the basin, the higher it climbs. This is why a megatsunami cannot cross an ocean. Its energy is local, but within that locality, it is without mercy. At Lituya, the wave did not need to travel far. The boats were anchored inside the kill zone. When the mountain fell, Howard Ulrich did the one thing that saved him. He did not run for the shore. He turned his boat to face the wave, head on, let out his anchor chain to its full length, and rowed up the front of it. His boat was lifted over the tops of the drowning trees. He later said he looked down on a forest. From above, he survived. One of the other boats was never found. Not the hull, not the men, nothing. When the water receded, it left a signature no one could argue with, a trim line. On the mountainside facing the slide, every tree, every shrub, every inch of soil had been scoured away, up to a perfectly sharp horizontal edge. Below the line, bare grey rock. Above it, untouched green forest. The line sat 1,720 feet above the sea. Geologists came. They measured. They did not believe it until they stood beneath it. A wave does not leave a guess. It leaves a watermark, and this watermark was taller than the highest point of any structure our species has ever raised from the ground. And here is what unsettles the scientists most. Lituya Bay has done this before. The same trimline pattern appears in the forest at older heights. From earlier waves, 1936, 1905, 1853. The bay is a machine. It loads, it releases, it loads again. And it is not the only one. A megatsunami needs 3 things: a steep slope, a body of water at its foot, and a trigger. The planet is generously supplied with all 3 in Norway, in Greenland, in Alaska, in the volcanic islands of the Atlantic and Pacific. Mountainsides are cracking. Above deep water, right now. In Norway, there is a mountain called Sunneset. It hangs above the Geiranger Fjord, a place so beautiful that cruise ships line up to enter it. One flank of that mountain is sliding slowly, measurably, centimeters every year. Geologists have wired it with sensors, lasers, and alarms because they know not if, but when. Roughly 50 million cubic yards of it will let go into the water below. When Sunneset goes, the models are not vague. A wave of roughly 270 feet at the slide, collapsing to 80, then 40 feet, as it races down the fjord toward the villages Hellesilt, Geiranger, where the warning time is measured in 10 minutes, maybe less. The sirens exist. The evacuation routes are painted on the roads. Everyone there knows their mountain is going to kill the harbour. And then there is the big one, the scenario that geologists argue about in Raised Voices, an island in the Atlantic called La Palma, a volcano called Cumbra Vieja. In 1949, Cumbra Vieja erupted, and a fault opened down its western flank. One theory, disputed, frightening, and impossible to fully rule out, holds that a future eruption could send an enormous block of that flank, hundreds of cubic miles of rock, sliding into the Atlantic all at once. If that block fell as a single coherent mass, and that is the crucial contested word, single, it would generate a dome of water, perhaps 2,000 feet high. At the island itself, that dome would collapse into a train of waves, racing across the open Atlantic at the speed of a jetliner. 8 hours later, those waves would reach the eastern seaboard of North America. The most dramatic versions of the model put the run-up along parts of the coast at 50 to 100 feet, Boston, New York, the barrier islands of the Carolinas, Miami. Tens of millions of people live within that reach. Now, the honest part. Most geologists believe the flank would not fall. As one clean block, it would more likely fail in stages over many separate events, producing waves far smaller than the worst-case headline. The 100-foot wall on Miami Beach is the extreme tail of the distribution, not the expected case, but here is the thing about extreme tails. Lituya Bay was an extreme tail, and it happened. We have the photographs. So, the question this channel exists to ask, if you are on a coast when a mega tsunami is born, could you survive? The answer turns on a single brutal variable, time. And in a mega tsunami, you will have almost none. A distant ocean tsunami may give you hours. A mega tsunami from a local landslide gives you what the fjord allows, often 10 minutes, sometimes 2. There is no time to drive. The roads flood and clog. In the first minute, there is only time to do one thing: go up. The single rule that decides who lives is this: if you feel a long, violent earthquake near a steep coast, or you see the water suddenly pull back and expose the seabed, you do not wait for a siren. You do not film it. You do not go to the beach to look. You move inland and uphill immediately on foot toward the highest ground you can reach. Every minute of warning you give yourself is a minute you were not standing in the kill zone. The people who die in these events are rarely the unlucky. They are the curious, the ones who walk toward the strange retreating sea instead of away from it, the ones who assumed they had time in a mega tsunami. The most dangerous instinct you possess is the urge to understand what you are seeing before you flee it. How likely is any of this? Lituya scale waves occur somewhere on Earth, roughly once a decade, almost always, in unpopulated fjords and bays where no one is watching. The Norwegian fjord collapses are considered effectively certain on a timescale of decades to centuries, which is why those villages are wired with alarms. Today, the Cumbra Vieja mega collapse is the rarest and most debated, possibly tens of thousands of years between full events, possibly something that never fully materializes as the worst-case war. But geology does not deal in comfort. It deals in inevitability on its own clock. Every steep slope above deep water is a wave. That has not happened. Yet, the mountain at Lituya waited millennia. Then, on one July night, it didn't. We do not run this channel to keep you off the coast. We run it so that the strange behaviour of the sea, the violent quake, the water pulling back, the line rising on the horizon, means something to you in the one moment it ever will. Not in theory. In the 10 minutes you would actually have, if this scenario stayed with you, subscribe to Scenario 0. We are going to keep standing at the edge of the unthinkable, calmly, without panic, so that if the ground ever shakes and the water ever runs the wrong way, you already know which way is up. Yes, in closing, no cadence promise.